let's now take a look at a very specialized two-dimensional collision. So if I have two masses that are the same, so some mass m traveling at some speed v to the right, and then I have the same mass, I have something else with the same mass m sitting at rest. So v initial, v2 initial equals 0. They're going to collide. Since the total momentum's in that direction, they're going to collide, and one's going to go one way, one's going to go the other way. So this is before, after, along that line, we have m shooting off at some speed, we'll just call it c, and the other m shooting off at some speed d. This is some angle alpha, this is some angle beta. I know momentum is conserved. Well, this has momentum in that direction right there. So mv. This has no momentum to begin with, so this is p initial. P final, well, this is shooting off at some angle theta, so this is at some mc, at some angle alpha, and this one is shooting down that way at some mass d, at some angle beta. And so this, if I add them together, is P final. In other words, they have to be equal to each other. So, well, let's just add vectors. Let's do it graphically. So I have MC at some angle alpha, MD at some angle beta here. And the sum of these two vectors, the resultant, needs to be my initial momentum, which is just MV. So the question is, well, if that's beta, this angle here is beta also. If it is a perfectly elastic collision, then kinetic energy is conserved. And so I have 1/2 mv squared, that's my total initial kinetic energy, is equal to 1/2 mc squared plus 1/2 md squared. If I multiply everything by 2 over m, those go away. And what I'm left with is v squared is equal to c squared plus d squared. Well, over here, if I take each of these lengths of vector here and divide by m, in other words, I just change it by whatever the mass is, I get a similar triangle of c, d, and v. And from the energy equation, the Pythagorean theorem holds true. Therefore, that has to be a right angle. So in the very specific situation of two masses that have the same mass, one's at rest, one is moving, if they collide, then the angle between them, alpha plus beta, must be 90 degrees. Now, if you're given a situation where the masses are the same but they're both moving, you can always shift it into a zero momentum frame, figure out alpha and beta, and then shift it back. There's another video where I went through some of that detail, and so there it is.